Hi, I'm Olivia Stork. I'm here with Team Combat Wombat with our Verilog project for EC551 Spring 2014 at Boston University. Our game is called Combat Wombat, as is our team, and we essentially made a top-down shooter-style game, think along the lines of Galaga, but what we wanted to do differently this time was use an NES controller for the player to play the game. That's what we've got here. So, what I have here is an MSP430, which many of you may be familiar with. What this does is it demultiplexes the signal coming from the NES controller. You can see different LEDs light up as I press different buttons. And they also light up at the same time if I have multiple buttons pressed at once, which is something pretty cool about the NES controller. So, how this works is there are 7 pins coming out of the end of the NES controller. 2 of them are unused. 1 is power, 1 is ground, and then we've got these 3 more interesting ones here. Pulse, latch, and data. Pulse and latch are inputs from the MSP430 in this case. It's usually the NES system. Pulse, or latch is first set high, and this tells the controller to save internally the current state of the buttons. Then the MSP430 sends in several pulses. At each pulse, the controller will read out a state of one of the buttons. The MSP430, the way I've implemented at least, uses a watchdog timer to control these signals. So watchdog timer interrupt occurs every 64 microseconds, and it'll tell the latch to go high. It'll tell it to go low, then it tells the pulse to go high, and then it reads out the state of that button. Once it's read out all the states of the buttons, it sends a high signal on these wires out to the FPGA. In this way, there's now 1 wire per button when there wasn't originally. So here we have the big overall functional diagram of how our entire project works. We have the NES controller entering in through the MSP430 and being demultiplexed. This signal then enters through the VHDCI interface on the FPGA and enters the button debouncer. This then enters the character movement control module, which enters into the VGA sprite drawing control unit. This unit takes care of drawing the player's sprite, the enemy sprites, the projectile sprites, background, and the boss sprite. There is a game state FSM, or finite state machine, which controls, are we in the start screen, are we fighting the boss, stuff like that. There's also a status control module, which takes care of the player's current score, the boss's health, things like that. And the VGA sprite handles all of these signals and outputs them all to the VGA screen. So one of the more interesting techniques we've used in displaying our sprites is what we call sprite hierarchy. When we load in the image of a sprite, such as the player's character, it has a big white border all the way around it, and we don't want that to show up on the screen. So what we've done in the VGA module is said, if we are trying to draw the character, but there is white, instead don't draw the character, draw the background tile that is supposed to be underneath of it. This is how we get our Wombat character to appear like it's walking right on top of the grass without having a big messy white box around it. So here we have the start screen of our game. As soon as I press the button start, it should start the game, obviously. Here we have all the first initial wave of cats. If I shoot one of them, it should disappear, and then they start spawning at slightly more random intervals because the LFSR starts deciding their new respawn locations. As you can see, when I kill one, the score bar on the right increases, and something very scary will happen once I reach the maximum number of enemies killed. And this is our crazy final boss. You can see he has a health counter that should decrease every time I hit it.